this video, we're going to just wrap up the last type of calculation for waves I'll be asking you to do. This is number 5 and 6 from the last video. So once we get to electromagnetic radiation, we'll see that the frequency of electromagnetic radiation is directly proportional to the energy that it has. And the equation is energy equals H, which is Planck's constant, times frequency. And down here is the value of H. And so in the really simple example, if I wanted you to find the energy of an electromagnetic wave with a frequency of 4.3 times 10 to the 16 hertz, which is pretty high. That might be like an X-ray or something. All I have to do is E equals Planck's constant, 6.63 times 10 to the negative 34 joules times seconds, and multiply it by our frequency, 4.3 times 10 to the 16 hertz. And remember, hertz are 1 over seconds, so the seconds times the 1 over seconds will give you 1, so they'll cancel out, and you'll be left with joules. Alright, now just plug this in your calculator, and you get 2.85 times 10 to the negative 17 joules. That easy. And I know it's kind of weird to think about how much energy a certain frequency of light has, but again, there's kind of two ways to think about light. One is as a wave and one is as a particle. So when it's a particle, it's called a photon. So this would be the energy that a single photon would have. And that's quantum mechanics, and you're not going to have to worry about that too much right now. All right, and then the slightly more complicated version of that same question is if I gave you the wavelength, and then I asked you to find the energy. So now you're just going to have to do, you're going to just solve for the frequency. So you know that, here, I'll do it this way. Velocity equals wavelength times frequency. So if we're looking for frequency, you can divide both sides by frequency. Boom, boom. You get wavelength as velocity over frequency. The nice thing about light, or electromagnetic radiation, is that it all travels at the same speed in a vacuum, which is c, the speed of light, which is up here. So this becomes velocity divided by frequency. The velocity you just plug in as the speed of light, 3 times 10 to the 8 meters per second. You divide that by the frequency, 3.7 times 10 to the negative 5 meters. I'm guessing that's somewhere around the infrared range. Meters will cancel out. You'll be left with 1 over seconds, which are hertz. Plug this into your calculator. You get 8.1 times 10 to the 12 hertz. Now that we have hertz, we can now solve for energy, just like we did in this question number 5. So now we have energy equals H, 6.63 times 10 to the negative 34 joules times seconds. We multiply that by the frequency we just got, 8.1 times 10 to the 12 hertz. Again, hertz are 1 over seconds, so the seconds times 1 over seconds gives you 1. You're left with joules. Plug this in your calculator. You get 5.37 times 10. Damn it. What do I want? Aha. There we go. We're back. 5.37 times 10 to the 21 joules. Nope, negative 21. Sorry about that.